next speaker is Dr. Karen Christensen.
Working? Oh, hold on. Yeah, it's good. Hey, good morning, good close to lunch. Thank you for Shauna for the opportunity to be here and visit with you today. So want to share with you kind of a journey that we've been on at Tyson Foods to really understand some of the important concepts around lighting broiler houses. And this is really an important issue right now because there's a lot of pressure on not only producers but also on customers to make some pretty significant wholesale changes to broiler production. And one of those changes that's being discussed is around lighting. Most of it's about higher intensity light or including natural light or windows into the facilities. And I think that there's a real concern about choosing the right intensity for light, the right way that we provide light to the birds, because it's definitely going to have an impact on their performance and on their behavior and ultimately on their welfare. So I'm just going to kind of take you through how we've arrived at a very novel way to light broilers, and we're beginning to commercialize that concept right now. But I think that where we started was, what is it to them? Why are we just picking numbers out of the air, potentially, and for the most part, and assigning that to the birds without really understanding the impact of light for these animals and inadvertently causing them distress, anxiety, and then, not only welfare, but performance is really gonna suffer. So I think we took the opportunity to really step back and understand how important light is to these birds, how they see the world, and then how can we use that information to provide them the best environment. And light is going to be a significant part of that environment. So I want to just back up just a little bit and remind everybody that a lot of conversation around welfare started back in 1964 when Ruth Harrison released the book Animal Machines. And that really began a public interest and a public outcry about intensive livestock, including poultry farming. And I'm sure most of you remember that this resulted in the committee that released what is now known as the Bramble Report. And I think that's it's an interesting milestone in welfare science, and certainly in the conversation about commercial agriculture. And if any of you haven't read the Bramble Report, I would encourage you to go back and read it. It's really interesting information. So from that Bramble Report, the Farm Animal Welfare Council was created, and what came from that committee was what we know today as the 5 freedoms. Okay, and I know everybody here is familiar with the 5 freedoms. Now at Tyson Foods, as we've heard a lot about today, we've moved or evolved. We have from the 5 freedoms to the 5 domains, and working hard to integrate that into everyday operations and everyday conversations with our team members, especially those that are on the ground floor of handling all the animals entrusted to our care. But I do want to point out something really important about the 5 freedoms that I found to be very interesting. And that is the freedom to express normal behavior for the species. So I found this video, and I would also encourage those of you that are interested in welfare to find this. It's on, you can find it easily on Google. It's a 10-minute video that John Webster, who pioneered or authored the 5 freedoms, gives his personal account of the development of that. And I'm kind of geek out on historical stuff and these people that were really instrumental in getting us to where we are today. And so I found it to be fascinating. I'm not going to share the whole video, but I am going to share with you the last 2 minutes of it, because I think it really sets the stage for a little bit of the undercurrent of what we've been hearing today. And so let's hear it directly from Dr. Webster, and then we'll talk more about it.
I think this concept of behavioural feeding can be interpreted quite sensitively, so long as one doesn't get too bogged down in box. However, in recent years, I come to believe that the fifth freedom might be better expressed as freedom of choice. This incorporates freedom to express natural behaviour with regard to choice of diet, environment, social contact, comfort and security, something being enjoyed by the Swiss cows on the alpine meadows in this final slide. So I believe this concept of freedom of choice addresses all the concerns set out in the original Bramble report into the welfare of farm animals in intensive systems. More generally, it addresses my greatest criticism of the whole business of factory farms, namely that when we assume more or less total control of the physical and social environment, it denies the animals the opportunity to make choices designed to promote their own quality of life. And that is my big and final point. Thank you for watching and listening. I hope you find this helpful.
Okay, John. Okay, so I think that this is really important. Where would we all be today if Dr. Webster had actually made the fifth freedom the freedom to choose? And I think that we're going to see a lot of new developments in welfare when we start to think about how do we incorporate choice into the production of these animals. So in addition to that, Dr. Marion Dawkins has a new book out called The Science of Animal Welfare, Understanding What Animals Want. And I think that it can very well be summed up by the statement that she provides us. What constitutes a good life from an animal's point of view can be made real by practical research on what they need to keep them healthy, but also on what they demonstrate to us that they want. Okay, so I think this is a reinforcement. This idea of animal choice is super important. So at Tyson Foods, I'm very fortunate to have a research facility for broiler chickens that's exclusive for conducting welfare research. And one of the things that's very unique about it is it's a full-size facility. So we have the opportunity to evaluate welfare concepts, whether it's lighting, as we'll share today, or even the work that we're doing with enrichments in a full-size barn. And I think that is critical. And we've seen today some questions and comments about how do you take this information done in research settings and move it to a full size facility, because there's a lot of differences. Small pens of animals are obviously very, I just talk what really the differences are. Small pens of animals have different dynamics than large facilities where we have, in my case, 20,000 birds per house. But I think one of the really important differences is the expression of where they're going. So in our facilities, if we put enrichments in, and you'll see this with the lighting, and they engage with it, they're taking a lot more steps than they would potentially in a small space, even if they have the same density as in a full-size facility. So I think it's really important that we start out small, but then we really make some final evaluations in these full-size facilities. So I think we've taken that to the idea that in our facility and with the issues that we're working with, animal preference is key to the decisions that we make. So as Dr. Dawkins says, we now have a wide range of methods for asking animals what they want, and we should have the humility to use this evidence to ask the animals rather than automatically assume that we know from our human standpoint. And I think in the case of lighting, there's a lot of push to put these broilers under higher intensity, or maybe to include natural lighting that humans are feeling good about. But I think the important part is we really forgot to stop and ask the birds, what is it, the kind of light that you want that'll make you feel safe and secure and ultimately improve your welfare. So this down is up thing is hard. So I guess I want to say that I approach this this project by saying, I don't care what the lighting is for birds, but I'm passionate that we come to the right decision. Because in my experience, when lighting isn't right, you can have a lot of performance issues and a lot of welfare issues that can go along with that. So we've really let the birds take the lead in designing these systems for themselves. But I want to stop a little bit here and let's start at the very beginning and say, why is light important to birds? Because there may be other aspects of their environment that's not critical. So we don't have to be 100% right. So let's think about, though, how do they see the world and how do we incorporate that when we're making decisions for them in regards to lighting? So we'll just go back and have a little reminder of how important lighting is to these animals. And I think it's fair to say, to start the stage by saying that we have to remember that they are prey animals. So in their pea brain, everything is trying to eat them. And so safety and feeling secure and free from the concern of predators is going to occupy a lot of their time. And so our goal is to really remove that from their world. So if we think about their eyes, they're very large compared to their size of their head, and both eyes together weigh as much as their brain. So we can already see that there's a lot of resources that have been committed to vision and sight. Okay, and if it wasn't important, I would think that some of these statistics would start to change, because if vision wasn't important, we would see less resources devoted to their eyes and to vision. So these birds have obviously we know where their eyes are on the side of their head, but that gives them a 300-degree field of vision. And so already we can say now, if I can see almost all the way around, then I have a pretty good idea of what's happening around all parts of my spot right here. And again, we think about this idea of prey concern. So some of the really interesting things, though, is they have both binocular and monocular view of the world. So what does that exactly mean? Well, it means that they can process two images, distinct images at the same time. Now, I struggle to keep track of my phone with two eyes and one image. These simple animals, supposedly simple, I think they make us all crazy, but they can actually process two absolutely independent images. And they use one of those images for close-up, which would be eating, scratching, foraging, and a second image that they'll use for distance, and that is for watching for predators. So when they're eating, at the same time, they're making sure that there's nothing pending that's taking advantage of the fact that they're slightly distracted. And one of the things that's interesting too about the way this develops is during incubation, the eye that's closest to the shell is the first to be exposed to light. And so one eye, it's always the same eye, develops differently than the other eye. So the right eye is used for close vision, and the left eye is used for distance vision. And you can kind of check that if you go into a house and alert those birds, they'll all look at you with their left eye. Part of that is because they don't have a corpus callosum, which connects the two halves of the brain, which allows them to process these two separate images. Their eyes are fixed in their skull, and so unlike us, we can change our focal length and keep things in focus by doing that with small muscles in the eye. They can't do that, and so we see that characteristic head bob, which is exaggerated when you watch pigeons. You're like, how could you do that without getting motion sick? Well, they're doing that to keep focus as they change their position. They do that to keep things ahead of them and around them in focus. Okay, so some of the other interesting things now about chicken vision is that we have 3 cones in our eye used for color vision, and that would be basically red, yellow, green in the spectrum, but chickens have 4. So we can already see now that there's going to be some differences that are going to change how the world will look to them. They also have an interesting double cone, which isn't used for color vision, but it is used to detect fast motion. And so if you ever wonder why a chicken can move out of your way faster than you can start the movement to catch that chicken and make you look like an idiot, it's because they can detect fast motion before it's almost been expressed. And I think a great example of that too is we're starting to see the starlings that are flying in these huge hundreds of thousands of birds and swarming and doing all that. And you wonder, how is there not collisions and birds raining down on the road? But they are able to, it's a little bit of communication, but also they are so able to detect that quick motion and respond. That's another way that they can keep safe and avoid predators. So if you think about the spectrum that we see here, thinking about the wavelength of light, you can see that we're most efficient in kind of in the green area, and it's a pretty smooth curve reflected by those three cones that help us with color vision. And I'm sure many of you have seen this. This is the spectrum as it would pertain to a chicken. So you can already see that there's some significant differences between how we see color and how they view color. So if I lay one over the other, you can see that there's two areas that are of significant difference. So then we need to think about, how do those differences in perception of light impact the way they see the world, and how when we present light to them is different than when that same light is presented to us. So let's look at some different lighting sources and compare it to humans and chickens. So there has been a calculation made to accommodate for that fourth cone and the differences in illumination. And so we call that CLUX, or chicken lux, or Galilux. And so it's a calculated number, and there are 1 or 2 meters available out there now that will give you light readings in both lux and CLUX. And we use that to understand what the birds are perceiving as we are investigating light. But to give us some good ideas, think about a 15-watt incandescent bulb, if we even remember what those are. For a human, it's 5.6 lux. That's not very much light, but for a chicken, it's quite a bit brighter. So not quite twice, but already we're seeing like, oh, so if I put them in 20 lux, that's 20 my lux, but how does the bird perceive that 20 lux is maybe closer to almost 30. So cool white fluorescent tube, there's still maybe some of those in chicken houses. For a human, it's 120. For a chicken, it's nearly 160. So at what point do we need to accommodate for this extra illumination? Now, remember we had that big area of blue light? Well, you can see that a pure blue light for us is about 40. For them, it's almost 5 times as bright. So I think it's very difficult for us to assign lighting programs for birds if we don't consider 2 things. One is what they want, and 2, how does it look to them? Okay, and then I think this one is really interesting when we're thinking about natural light. Sunlight at noon in the UK, I guess that happens occasionally in the summertime. It's 100,000 lux, so it's very bright. But look for a bird, 163. But so when does 163 lux become too bright? And we're accommodating that. We all wear our sunglasses at the beach, but we're not making any accommodation for them when that world is going to look very, very different. And if you're a prey animal, you probably don't want to be that visible. Okay, so we said, how in the world did we make decisions if we don't ask the birds? So we started out, this is actually a project I started when I was on faculty here at the university, just asking the birds, what kind of light do you prefer? So at that time, we had a number of pens set up, and we actually had used a commercial house to set the pens in. And we had 3 different light intensities as listed here. And then we were able to measure feed disappearance, and we were able to measure position of the birds over time in the different pens. And what we found out was that they consumed feed highly statistically significantly in 20 lux, with very little feed being consumed in 5 or 10 lux when they had that choice to make. But I think what was even more interesting is when we evaluated where the birds were hanging out when they weren't eating, was that they chose to be in the corridor at 5 lux because the whole house happened to be 5 lux, and that's just where this transition area happened to be lit at 5 lux. And I think that that ended up being a really good indicator that helped us understand what these birds want, because they didn't hang out at 5 lux where there was feed and water, but they preferred 5 lux where there were no resources. So I think this is another indication that when you're a prey animal, to really rest and feel safe and comfortable, you don't want to fall asleep near the resources, because the things that you're trying to avoid are going to access those same resources. So I think they really told us that they want to eat in the bright light, but they don't want to be around those same resources when they want to rest and feel safe and secure. So we published that in 2019, and that was really the beginning of this journey of developing light for them. So the next piece was using this idea of bright light and dim light, and the fact they don't want resources in the dim light. Once they've chosen that, can we verify the fact that that's a good choice? And I like to say, if I had the choice between cookies and broccoli, I wouldn't make good choices, but I want to know if they're making good choices, and can we measure that? So I think one of the challenges we all face is it's really easier to find out what's bad or how bad things are, but really thinking about how do we get to the good parts and positive welfare, I think is a little more challenging. So we set up this study to look at 5 different lighting situations that included our choice light of 2 and 20 lux, which obviously gives us a gradient of about 1 to 10, and then looked at industry standard lights, and then 100 lux being obviously very extreme. So let's look at some body weight information. This was done in pens, so it's small numbers of birds. But you can see that as expected, the 100 lux light had a significant impact on body weight. The others, not so much on body weight, but I think we were excited that on the choice light, it's still definitely in contention. So it didn't tell us that having the ability to move between lighting intensities would be negative on body weight. And we're really not looking to improve growth rate. We need to manage the growth rate that we have. So we're not looking for ways to increase body weight. So as long as it stays fairly neutral, that's not a bad thing. However, feed conversion, or the efficiency in which these birds convert feed to meat, is critical for us. So when we look at feed conversion, at least numerically, the choice light was numerically the best, and again gave us a very positive indicator that this might be something that's positive for the animals. And as a production person, setting aside the research hat, when I can look at what's that, 12, 10, 14, 16 points, 10 points, 5 points in feed conversion, I would do backflips to get anything even close to that in the production world. So a really good indicator that there's something here that we needed to continue to evaluate. And then with the help of my collaborator back here, Dr. Kang, who we really appreciated on this journey, we did take the step to look at this idea of positive welfare. So we really wanted to focus on the areas of the brain that would be reactive to light, and we chose to look at serotonin and dopamine levels. And then Dr. Kang convinced me that we weren't going to look at just serotonin and dopamine levels, but we really wanted to know how hard they were working to maintain those levels. So we know that serotonin and dopamine are really important for mood stabilization, but it's always going to stay fairly constant. What's going to change is how hard they're working to maintain those levels. And in a less stressful situation, we should see reduced levels of the rate-limiting enzymes for serotonin and dopamine. And that's exactly what we saw. So you can see here that at 2 lux, 10 lux, and 20 lux, they're all about similar. Nothing really amazing differences there. 100 lux, as expected, those birds were even more discomfort. and we would not encourage to use 100 lux, but it really did give us that high level there that as we expected as part of the validation. But when we looked at the numbers for the choice lights, these birds really indicated that stress is less, and they're just coasting and not having to use up serotonin and dopamine that's going to have to be replenished. So this was a really good indicator that this may be a strategy that's positive for birds. They chose it, and perhaps they actually made a good decision for themselves. So then if we move to some field trials, and we've done a number of field trials, but this is one set of trials that were done, 4 trials that were done as part of a project that was funded by U.S. Poultry and Egg. We looked at the performance numbers at scale, so in these commercial houses. And in these houses, we do a lot of things to remove as much of the field variation as we possibly can, knowing that it's challenging. But we use migration fences as we would in all commercial houses. So each house has essentially 4 defined sections, and we have 4 houses, so therefore we have 16 sections. And when we bring the chicks from the hatchery, we identify the potential source flocks, and then we divide those source flocks into 16 mini flocks. So the genetics in each of those 16 sections are identical to each other section. And so we do a lot of things like that in order to try to identify and eliminate as much variation as we can, which obviously is a challenge in a big house. So I know it's a lot of numbers. So what I did here is I took the choice lighting or variable lighting and boxed it in the red box. And the first column would be daily gain. And then I indicated in green the highest daily gain. And you can see for the most part that the variable light house did see an advantage in growth rate compared to either 5 lux, 20 lux, or NL, which we abbreviated for natural light. 2 of the houses at the facility do have windows. So when we need to use windows as a treatment, they're available. When we don't, that we're able to securely cover them and prevent any light contamination. So this really fits well with what our preliminary study in the pen was, that we are getting a touch better weight gain, which is great. But I would call your attention to the feed conversion side of the equation. And again, I set the feed conversion of the variable light houses to 0. And you can see that in most every case, we are somewhere between 2 and 10 points better in feed conversion. And this is very significant from a lot of ways, because the 70% of the cost of growing a live bird is the feed. So the more efficient we can be with the feed, it's certainly a reduction in cost, but it's also a significant reduction in the amount of acres of corn and soy that would have to go into that additional grain. And that's where it becomes an important measure of sustainability. So this is really important. The other thing that's been interesting in this project is that we have observed that there's been a lot of other natural behaviors that have sprung up in these houses with the variable lighting. For instance, we see 4 to 5 times as much dust bathing in the variable light houses as we do in houses that are either 5, 20, or 20 lux or natural light. And this is something that's very, very consistent. I was in the houses with some visitors last week and then again this week. And you probably will see more birds dust bathing in a 30-minute period than you would in several visits to any conventionally lit broiler house. And we're excited about that because these birds are very disengaged when they're expressing this behavior. And I think it's another indicator that they're feeling very safe and secure to exhibit that behavior right in front of people's feet when you're standing in the chicken house. As several other people here, we've also looked at activity monitors with the idea that if these animals then can choose to come to the feed to eat and then leave that area to go do something else or to rest and feel comfortable, that we would see an increase in physical activity. Now, you would think normally that physical activity would be contra to improved feed conversion. But I think what this really demonstrates is the fact that we are really focusing on voluntary movement. So again, the animals have a choice. They're walking, which I think is a positive thing for them to do, but they're walking because it's their choice to do it and engage in it. They're not feeling anxious because I'm exposed in very bright light and I'm just running and I have no reason why, and I don't know if it's doing me any good, but it's showing other things that are very negative. But now we have a very conscious plan that I'm going to eat in the bright, I'm going to play in the bright, and then I'm going to leave that area and not just plop right down here because, as Dr. Webster would say, there's absolutely no reason for me to move to there or there when it's all the same. Now I can say, oh, I just ate and I drank, and I think I'll go over there to take a little bit of a snooze. And so that was backed up by the activity that we tracked using some accelerometers that were Merck helped us with, and we certainly appreciated their help. In addition to that, we've seen some improvement in litter quality. So this graph is set up so that it's an indicator of sections of the house with over 35% moisture. So you kind of have to flip it on its head a little bit. And you can see that the variable light house numerically had the driest litter. And that is also reflected in foot pad lesion scores, where we're looking at fails, and we're seeing improved foot pads in these houses, probably because they're moving the litter a little bit, and hopefully results in a little bit of a better environment. So we talked about the dust bathing, but I think this is really, really significant and something that when people come into the house, it's very, very obvious what a social behavior and how different it is in expressing that than in conventional houses. So how can we use this information now to develop lighting strategy for broilers? So we know how they see the world, or we think we do. We'll never be able to view it the same way, and especially if you think about, they're part of UV light, which is, I think, another opportunity that we have. But what is it that about the things that we've learned to this point that may result in better efficiency, better behavior? And so we go back to the original idea. Is it because of a greater amount of movement? Is it because voluntary movement? Is it better because they have a choice? And one researcher in Europe, we talked about choice, and she said all animals' brains, including ours, are made for choice. And I think back during COVID, Arkansas here, we were pretty free to continue to live our lives. But, there was a few times when I just wanted to go to a restaurant and have dinner, and I couldn't. And was that a big deal? Absolutely not. But I felt that. And so I think that this idea of choice is something that we all need to consider for these animals. And it's very exciting to hear that this idea of choice is becoming a common theme amongst everybody. So I think this is really exciting. And then I think the other piece of this is it's really approaching natural behavior. So we are providing them now with areas to come out into the bright and eat, and then places where they can go and feel safe and free from predators. And so we've got this, again, a number of papers that are presented. Now, this is really an interesting new technology. I'm sure I mentioned a couple of times Dr. Marion Dawkins. She was part of the McDonald's Smart Broiler research grant that was initiated a few years ago in combination with McDonald's and FAR. And all of those researchers that are funded for that project, at least for the second half, are participating in our facilities, and we've given them barn space and all the technical support from that perspective to advance that research. So we provide the researchers with all the data from the birds on the farm. So how many birds, mortality culls, leg culls from every section of every house, every water consumption, temperature, humidity, everything that they need, but we don't ask for anything in return. Because we want them to freely develop their technology without any influence. But about 2 weeks ago or so, she sent me an email and said, comparison of feed line lights against 20 lux. And I'm like, oh, not having any idea how that was going to shake out. So with the OptiFlock technology, which is how she measured the welfare of these flocks, is she uses cameras mounted in the ceiling, and it measures the speed and an amount of movement in the flock. So not focusing on individual birds, but really looking at the shift between black and white. So birds versus floor space. And this technology in the early stages has been very accurate in predicting things like paw scores, Hochburns, Campylobacter of all things. And from that, she's also developed a welfare score, that birds that are falling higher on her welfare score will finish better with better KWIs than those lower. And of course, Dr. Dawkins is located in England, and most of Europe has strict regulations about lighting. Most of those have a requirement for 20 lux. So when I looked at this OptiFlock score that was created and generated by somebody working in that requirement, you can see that the welfare score of the feedline lights is significantly higher than the welfare score of the flocks that she evaluated that were under 20 lux. And I think her response to this was, oh. And then this corroborated with our accelerometers, and this is amount of movement demonstrated by the flock. And again, you can see that at least by day 10, that the feedline lighthouses were in fact moving more compared to the 20 lux houses, even though we continued to see better efficiency with that movement. And again, I strongly believe that this is a voluntary movement. We see a lot of play activity, sparring, running, just wing flapping, and all those desirable behaviors being exhibited in the light area of the house basically between the water lines, and then a distinct difference in behavior as they move into the dimmer areas. So this is actually a picture of feedline light house. I think looks pretty good. The cameras struggle a little bit when there's such a strong contrast, but basically the lights are mounted to the feed line. They're every 8 feet apart down the length of the house. Under the light, it can be as bright as 120 lux, and then at the center of the house or at the wall, it's about 3 lux. So it's a very distinct gradient. We've also asked a number of behaviorists if they thought we should have the same amount of light down the line. Should we have a light at every pan? And uniformly they said, no, absolutely not. That again, we want these birds to make a choice. We want you to choose between a dark pan and a bright pan. And the first 14 days, we definitely see a preference for feeding activity around the bright pan. But after 14 days, there's equal distribution of utilization. And that's also reflected in the lack of condemnation from things like scratches or IP and things like that. So there really isn't aggressive types behavior that is demonstrated. And I know with the turkeys, and certainly when you think about breeders, the one huge advantage that we have, I've really come to appreciate this working with broilers, is we don't have, likely aren't going to see injurious kind of territorial behavior and dominating behavior, because I think of these guys, and these are my kids, I think of these kids as being pretty much a bunch of first graders, and they're still really into sharing and acting nice. So we don't have that complication of ownership and territoriality and stuff that I think can be seen as any animal species gets older. And we're doing the same thing with enrichments and trying to understand how many enrichments are necessary, who's using the enrichments. And just kind of as a sidebar, I really thought that we would see that there would be, we use the huts, and the huts for broilers may be good because it's 2 things: safety and shelter, but also maybe mom for the few weeks that they're really with us. We thought, well, are we going to have the hut gang? That's like, it's mine. But in fact, we only see about 5 to 10% of the repeat birds, because we mark them and then monitor their behavior. We're only seeing about 5% of those birds coming back at any one time. So there is a tremendous number of new faces coming and engaging with our enrichments during that period of time. So I would say that, maybe we took a really long time to come up with something that looks very similar, and at least in my mind, to how these birds would prefer to live in the wild. Maybe we could have spent a nice weekend in the tropics and figured it out in a weekend. Instead, we took 5 or 7 years to figure it out. This is kind of an illustration of the light intensity. So the red circles over here, backwards on this side, would be the feed pans. We're using 5000 K, and then the brighter or more yellow and red, the squares are the more intense the light. So you can see it's roughly goes from over 100 lux to 3, 4 at the center of the house, and then that would be repeated again at the wall. One of the other kind of things that have come up with the system that wasn't part of our initial thinking was this is a 24-volt system, and so the amount of electricity that's used for this is very, very low. The other thing I think it's important for poultry is this is a DC system, and so we don't experience any flicker in the light. So I think that's another positive. But from a sustainability perspective and a grower perspective, we calculate that they will save anywhere from 60 to 75% of their electrical cost that's used now for lighting those chicken houses, even when those lights are LED lights. So we believe it's a win for the birds, it's a win for the growers, it's a win for the planet. And I'm excited that this system is being accepted by some of our major customers, and we are just now beginning the installation in 3,100 houses. So with that, I appreciate the opportunity to visit today, and happy to answer any questions.
All right, we have time for 1, maybe 2 questions, but we will have a roundtable after lunch. So the most burning of questions may ask theirs. People might ask them. No? All right.
Say, Karen, whenever you were looking at the difference in feed conversions between the different treatments, was any of that attributable to mortality? Did you see differences in mortality between the groups?
No, that's a good question. So no, our mortality has been fairly consistent. I will say that we are seeing a touch better leg health. And so some of that may be attributed to reduction in leg culls that are being removed. So that's obviously a positive. We can get those birds raised without those leg issues. So again, that's a real positive that the idea of leg health is improving. The other thing that we're just touching on is it appears that there is a positive change in metabolism in the liver against a 20 lux house. And so we're thinking that just, again, another indicator that stress may be playing a part in this as well.